So welcome Meg and Sarah and Maya, and welcome Braulio. Thanks for coming. Let me talk about what we're going to do today. So I'm going to share my screen. Okay, so the plan, as always, I'll start out with any questions you might have. And then we're continuing on this whole hypothesis testing. And actually, I didn't write it in, but we're also going to do confidence intervals too, because they go together. And so the nice thing about today is it reinforces what you've been doing the last few weeks. And what we're going to be doing, though, is we're going to be doing something that turns out to be very useful in hypothesis testing, much more useful than what we did last week. But last week was a good kind of, easy walking into it. And what we're going to be doing now is talking about how do you compare two different population proportions. And we'll have a hypothesis test and a confidence interval for the difference between two proportions. And then we'll do the same thing with means. It turns out, though, with means, there's two types. And one is when you have independent variables, and the other is when you have dependent variables. And I'll talk in depth about what that means and how do you tell one from the other, which one to use. So this chapter 10, what we're talking about, and it's all about comparing two different groups. Okay. And it could be comparing the answers to two survey questions also. So it could be the same person answering two questions, but either way, it's a comparison study. And comparison studies are, at least in my experience, are done more often than single observational studies. Everyone wants to compare because we want, my stuff should be better than your stuff kind of stuff, or the old stuff. So this is all about comparison studies, or maybe this year has changed compared to last year, and you're going to compare the 2 years. That's what I'm talking about, comparisons. The good news, it's kind of good news and bad news. The good news is, I'd say content-wise, this might be maybe one of the easiest content weeks there is, except for the last week. But the reason for that is because there's a lot of stuff coming up. So hopefully you all know what is coming up at the end of this week.
The exam.
The exam. So that's why I'm a little, it's definitely a lighter week in terms of material, because you got an exam this week. And you got to make sure that you get ready for that exam. So I'm going to be talking about strategies for the exam, details about it, kind of a bullet pointed explanation of what's on the exam. Let's call it that. So we're going to talk about that. And then what comes after that, the week after that?
The projects due.
Yeah, but project 2. So you got a lot of stuff coming up, and that's why this is a lighter week. And, chapter 10 is definitely not the hardest chapter in the book or anything like that. That's not why we just do one chapter. It's one of the easier ones. That's the good news. And it's just a repeat of the last one with a couple little extras. That's really what it is. So that's just a note. The project is due, and the project is all about chapter 10. So after today, you're going to be able to come up with your project idea. So I'm going to talk a little bit about the project. We talked in pretty much detail last time, but now we can talk about the content of the project, the details of the project instead of the ideas of the project. So that is the plan of the day. And I want to let you know, don't get confused about this week in terms of the discussion post. There is no discussion post assignment due this week, because I decided I should be a little light on you guys in terms of assignments so that you can get ready for this exam. So if you're looking for that, discussion post assignment, you're not going to find it. So if you love them, I'm sorry, but this is the week of lots of other stuff going on. Okay, so that's just a note, no discussion post assignments. There will be, we'll go back to it next week, by the way. So it's not over forever, just this week. So, but there's still the chapter 10 regular assignment. Okay, and that's a normal assignment. So are there any questions about anything before I start talking about new material? Any questions? Okay, if there's no questions about anything, then I think I'll move forward and we'll talk about chapter 10. So as I mentioned with chapter 9 and 8, we looked at confidence intervals and hypothesis tests when you wanted to compare some population to some known number. But usually there isn't some known number you want to compare it with. Usually you're comparing two groups. That's normal. Okay, not always, but more common. So I want to start out, and I'm going to do it by example. I think that's a good way of talking about these things. And I have a question. And it has the percent of Americans who consider race-related issues the most important problem in the US changed over the past month. So that's a big question. Okay. And we want to interpret the 95% confidence level also. Okay. Confidence, you write interval instead of level. Okay. So that's the idea, is we want to be able to compare last month to this month. And the good news is that if you go to Gallup, you can find a survey that was done. So let me click on that, and then I'll talk about it. Okay, so again, there was an article by Gallup. And I like Gallup because they give you the sample size and they give you all the information you need. So that's the good news. I'm not saying that you always have to use Gallup, but it's good for this class. Okay, and it's heightened racial concern, a clear legacy of Floyd's death. Okay, and my guess is that, I don't need to explain all the history because I think that everyone knows by now what's been going on in the last year or so. And it's 11% of Americans name race as a nation's top problem in May. All right, so what we can do is we can scroll a little more. And we can look at recent trend of mentions of race-related issues as the most important problem facing the United States. So in May, it's 11%. Okay, in April, it was 12%. So has it gone down? Right, it was 12% last month, 11% this month. Has it gone down?
Yes.
Yes.
Okay, I want to let you know it was a total trick question. Okay, and it's a trick question because I think you all know, I hope you all know, that Gallup did not survey every American, every single adult in America. That's not possible. In a month time, no one's going to be able to do that out of the hundreds of millions of people we've got in this country. This comes from a survey. Both of these, each of these come from a sample. Does that make sense? And the question is, do we really know it went down, or maybe it's kind of random chance that they just happened to ask those people, and by random, more people or fewer people this month said yes, even though maybe it's the same in America. Does that make sense? So what we need to do is we need to come up with a hypothesis test. Any questions on that idea? So that's the main thing, is we need to come up with a hypothesis test. And I'm hoping that you all know at this point that when you have a hypothesis test, you need to have an H naught and an H1. Y'all good with that? So I'm going to put in H naught. Colon. Okay, so far nothing's changed, right? But here's what's going to be new. What we're doing is we're comparing last month's proportion to this month's proportion. Okay, whereas before we wanted to see if, say, what we are now is equal to some population that we know about, but we don't know either last month or this month. We only have a sample. So what we can do is we can say our hypothesis now is not going to be something like our P is equal to 0.12, because that was last month according to Gallup, but that's not the true number. No one knows the true number. Instead, what we're going to say is, and I'm just going to write P2 equals P1. And let me write down where P2 is the population proportion of Americans who think that race-related issues are the most important this month. Okay, so let me put that online. Actually, it'll be better. And now I'm just going to copy and paste and change it to a 1 in next month. So P1 is the population proportion of Americans who, I guess I should say thought instead of think, since it was last month, thought that race-related issues were the most important problem last month. Any questions on H0? Okay, what is H1 going to be? And what's the key word that's going to tell us what H1 is? So if you look at the question here, what's the key word that's going to tell you what inequality to use? There aren't that many words in that question.
The most?
Not the most. It's a good idea, but not the most.
Changed.
Changed. Yeah, changed is the key word. Because if it's changed, that means the proportions are different from each other. Any questions on that? So H1, and the idea is basically very similar. So I can copy and paste, change the 0 to 1. And then change the equal to, since we got changed, that's going to be a not equal to. Any questions about developing this null hypothesis and this alternative hypothesis? That's kind of what's new in this chapter. It's not that much new in this chapter, by the way. But what's new is that we no longer have just P is equal to some number. Now we have two population portions we don't know, and we want to say, are they equal to each other? So they're both variables. Any questions on that? Okay. And then hopefully, again, the change, that's the same as last week. The word change gives you not equal to. That is really exactly the same. Any questions so far? Okay, so now we have that. Now it's just, we do what we're used to, and that is we get all our information. That we'll get here. First thing is our sample proportion was 0.12 for P1 last month. And for this month is 0.11. That comes from the article. Any questions on that? So let's go ahead and write those out. So what we can say is that P sub 1 and then there's a hat over that P. That is that one, I think. There we go. Kind of weird looking hat, but that's okay. I think I need to, well, I'll leave it. Is equal to P hat sub 2. Sorry, P sub hat 1 was equal to 0.12. And P hat 2 was equal to 0.11. Any questions on what these mean? The sample proportion for last month was 0.12, 12%. And the sample proportion for this month was 0.11. Because Gallup did the survey every month. Okay, we also need sample size. There's not going to be 1 anymore. Now it's going to be 2. And if I remember right, they give you the most recent. So I might make up another one just for this class. So the May one was 1,016. So let's write that out. So that is N2 is equal to 1016. So N2 means the second sample size. And then N sub 1 was equal to, I believe it was 961, if my memory is right, for last month's survey that Gallup did. Any questions so far? Clear enough? Okay, so we've got that. And this is kind of new stuff, political science. So 0.05 is the right level of significance to use. So in particular, what do you think the next step is? Now that we have our null hypothesis, our alternative hypothesis, and we have the important numbers.
Calculator?
Yeah, we go to a calculator. So hopefully you're used to that. So let's go to the calculator. See if you can guess which one we use. So which calculator?
Hypothesis test for a proportion?
Okay, that's a good idea, except that we're comparing two proportions. So hypothesis test for proportion was the last chapter when we had a single proportion where we just had a p equals greater than 0.5 or something like that. So that one's not going to do it for us.
Number 19, two proportions?
Yeah, number 19, we have two proportions this time. So notice, and we're going kind of order the class. That's how I made this, is that we're basically 17, 18, 19, and 20. That's chapter 10. So we're on number 19 because we're talking proportions. Any questions so far? Okay, so our sample sizes, our N1 was 961. So 961. Our second sample size, that one was 1,016. How do I get the number of successes for the first sample? How do I do that? So what do I have to do to find the number of successes? It's only indirectly given here. It's not directly given. Who remembers how to do that? It's the same as last week and the week before. Any thoughts?
Do you multiply P1 times N1?
Exactly. Exactly. If I take 0.12 times 961, that's 12% of 961. That's how many people said yes. So 0.12 times 961. So I'm going to go to my scientific calculator and just type it in. So 0.12 times 961. And I get 115.32. And we should round using the rules of rounding. So 115. And similarly, I need 11% of 1,016. So that's 0.11 times 1,016. And that looks like about 112, rounded to the nearest whole number. Okay, and I want to note something. Again, everything we're doing here is basically just an extension of what we did last week. So for example, last week you had to have that NP and NQ were both bigger than 5. And NP was the number of yeses or successes. So same thing, except now we have to do it for both samples. So notice 115 is greater than 5 and 112 is greater than 5. That's our NPs for NP, kind of N1P1 and N1Q, N1, N2P2. And then if you want to find out the number of no's, you can always subtract. 961 minus 115 is very large, bigger than 5. Same thing with 1,016 minus 112 is definitely bigger than 5. So that means our sample size is large enough. Any questions on that piece? We had a not equal to for our alternative hypothesis. Let's use 0.95 for the confidence level. That way we can get everything at once. And I hit calculate. Any questions on that? Okay, Z equals 0.657, etc. That's the test statistic. So if I ask you for the test statistic, that's this guy. The p-value is right here. What do you think this tells us if our p-value is around 0.51? What does that tell us? Hopefully, you know, it's the same as last week. Nothing's changed.
With a p-value of 0.51, doesn't that mean that our results are invalidated? Or
Yeah, statistically insignificant is the way we use it.
it's insufficient, insignificant.
Yeah, insufficient is fine. I mean, invalidated is probably not the right word, though.
Okay.
But yeah, the right idea. Yeah. Invalidated you usually use when you screwed up the test. So insufficient evidence or statistically insignificant, that's what you use when either they're the same or maybe your sample size is too small. Does that make sense? Just the language.
Yeah. Thank you.
Yeah, but I think you had the right idea. Okay, and then the lower bound for the confidence interval is about negative 0.02, and the upper bound is about negative 0.04. Okay, approximately. So now let's go back, and we can say there is statistically insignificant evidence to conclude what we wanted, which was H1, and H1 is that P1, T2 is not equal to P1, or the population proportion of all Americans who, and I'm going to copy, consider race-related issues the most important problem in the United States. So I'm going to copy and paste that. So I'm going to type it all. Has changed from last month to this month. Any questions? Any questions on that? Okay, is this feeling very similar to what we did last week? Hopefully you say yes. Yeah. The big difference is we have two proportions instead of one, but it's really exactly the same process. So that's a good thing. Once you totally understand hypothesis testing, then there's just little tweaks that you do to be able to do whatever you need to do. Any questions on this? Any questions? Okay, I'm not going to type it all out, but same idea with the p-value. The p-value is 0.51. So that means if the proportion of people last month and this month, the population proportion of people last month and this month who consider race relations the most important problem in the United States hasn't changed. And we did another study last month of 961 and this month of 1,016 people, then there would be a 51% chance that, and now notice that the proportion we got was 1% difference, that there'd be at least a 1% difference in the proportion month by month. So exactly the same idea. Okay, and same with the level of significance. If the population proportion of people who thought that race-related issues were most important problem in the United States was the same last month and this month, and if we did another study of 961 last month and 1,016 this month, then there'd be a 5% chance that we'd end up falsely concluding that the proportions have changed. Okay, type 1 error. Okay, so it's exactly the same as what we did last week. As I mentioned, what I have typed out is the most important. So I want to make sure you really understand that. The others, they're nice and important, but not quite as important. Okay, the confidence interval, notice was, again, negative 0.02 to 0.04. So let's write that out. So 95% confidence interval. Was negative 0.02, comma 0.04. So we notice, even if it's changed, it hasn't changed much. Do you all agree? That's a pretty small percent change, which we kind of see from our P1 and P2. So that means with 95% confidence, the population proportion, let's write it out. Let's go here. The population proportion of all Americans who consider race-related issues the most important problem in the United States has, we can say has increased by no more than 2% and decreased by no more than 4%. Right, 0.02 is 2%, 0.04 is 4%. Okay, and notice, by the way, if this is subtracting the first minus the second, and that's how that works. Okay, second minus first, sorry, that's what I meant. Any questions on the confidence interval interpretation? Hopefully you're seeing that it's really the same old stuff. You seen that? Okay, so it turns out that actually, work on this stuff this week will help you practice for the test, even though this chapter isn't on the test, because it just gives you more experience with confidence intervals and hypothesis testing, which is what a big part of the test is. for the exam you're taking at the end of the week. Any questions at all on this idea? So again, there's not really any big new material to talk about, but now we have just two different populations. Okay, so now I have another example. And that is, do single women spend more time cooking than single men? Okay, might be something that, you know, somebody might be studying, researching. The 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. The 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 16 minutes. What can be concluded at the 5% level of significance? Also interpret the 95% confidence level. Let me go interval, because that's more important. Any questions on the question? Okay, I do want to give you a disclaimer, and that is, unlike the last example, this one, I totally made up the numbers. Sound like a good example? Okay, so, you know, don't quote me on this. There wasn't really a study done, but a study could have been done. You could do a survey like this. It wouldn't be a tough one. How is this different from the last one?
Standard deviation.
Standard deviation, that's definitely there and the other wasn't. But even more important, how is this different? Because there's definitely something very important that's different. Anyone see?
It's using the mean instead of proportion.
Yeah, that's the main difference. And I've mentioned the last few weeks that's like the number one thing you got to get down is know whether you're talking about a yes/no survey question or a quantitative survey question. Okay, the survey question here, how many minutes did you average cooking, right? Okay, a day. And the person's going to say, I average, 58 minutes or something like that, or 42 minutes or something like that. But it's not a yes/no question. Whereas the last one was yes/no. Any questions on that? And it changes everything. Okay, so I'm going to go new equation. I'm going to go H1, H naught. So instead of P, what do I use?
Mu.
Yep, mu. And now it's going to be, let me write mu. So mu. And we're comparing women and men. So how about mu sub W equals mu sub M for women and men. And that way we can really see what's up. Just want to make it bigger so you can see it. Okay, then we're going to have an H1. Again, nothing's different. We still have H naught and H1. And then you put a colon. And we're going to have a mu sub W. Let me just copy it and we'll make an adjustment. What inequality do we need now?
It says more, so greater than.
Yep. Women are greater than men. Okay. Any questions on that? Easy enough? Okay, so hopefully you're seeing this is, working. Is the sample size big enough that I don't need to make any assumptions? What do you think?
Yes.
Yeah, because we have two sample sizes. One of them is 35. The other is 38. In fact, let's write that in. So N1 or n, come on, let me in, n sub w equals 35, and n sub m equals 38. Both are bigger than 30, and that was the important thing when you have quantitative data, you got to be bigger than 30. With the yes, no, it's NP and NQ bigger than 5. So we know that. We have the mean, we have the standard deviation. So I'm not going to write it out because it says basically is that we can say that the X bar sub W is 58 and S sub W is 12. And similarly, X bar sub M is 46 and S sub W is 16. Any questions on that? Any questions? Okay, so now that I know that, what do I do? What do you think's next?
Go to the calculator.
Yeah, we go to the calculator. Is it the same calculator? Will this work?
No, because that's for proportions and we're doing mean.
Exactly. It's not a two proportion calculator. Let's see what we got. So I can go back to the calculator menu. And then there's something I want to talk about because there's all kinds of different calculators. So we have two independent samples with data, two independent samples with statistics. We also have two dependent samples with data. Okay. So first thing is dependent versus independent. So let me tell you about what that means. Dependent data means that typically you could be asking one person two survey questions and you're comparing the answers to the two survey questions. So it's the same person giving you two numbers. Or it could be, you might look at maybe 50 days of the year and maybe you're going to look at the weather in two different places for each of those 50 days. That would be dependent. Instead of it's one person giving you two numbers, it's each day gives you two numbers. Does that make some sense?
Can you
So
say that one more time? Yeah, say that one more time.
Yeah. So if it's 50 days of the year and you're looking at, say, the weather in San Francisco, maybe the high temperature in San Francisco, and maybe the high temperature in South Lake Tahoe. For each of those 50 days, that would be dependent because for every day there's two numbers. So if for every instance there's two numbers, it's dependent. Okay. Another example might be, let's say you're looking at food prices at say Safeway versus Raley's supermarkets. And you're going to look at 40 different foods. So maybe oranges and I don't know, macaroni and cheese and, 40 different types of food that you can find at both places. And you're going to look at the prices of those foods for each of the two places. That would be dependent because for each food, you get two numbers. Okay. On the other hand, we don't have anything like that with our example. Okay. We're talking about men and women. These are not married. This isn't husband and wives. These are just a bunch of men and a bunch of women. There's no pairing. There's not two numbers from one thing. Does that make sense? So these are two independent populations that we just grab 35 women. We grab the 38 men. These people have nothing to do with each other. They're independent. So this is an independent sample. So we're going to use independent samples and we have statistics, not data. Any questions on that? And then we pop our numbers in. So our sample size for the first sample was 35. For the second sample was 38. The sample mean for the first sample was 58. The sample mean for the second sample was 46. And again, the first was women, second was men. Standard deviation for the women, the first sample was 12. Standard deviation for the second sample, the men, was 16. Any questions on that? We think the women are greater than the men in number of minutes they spend. So greater than. Confidence level, let's let be 0.95. Any questions on that? And I hit calculate. Any questions so far? Okay, so now we have a T, very similar to when we had a single population mean and we're just looking at that one population. It was still a T, if you remember the test statistic. So the test statistic is 3.64 about. The p-value here, what do you notice?
It's very low.
Yeah, it's very low. If it's very low, what does that tell us we do?
It tells us it's statistically significant.
Exactly. It's statistically significant because we have a small p-value, because it'd be very unlikely for this to happen if H naught were true, which means we're going to say H naught isn't true. That's what this is all about. Okay. We have an upper and lower bound for the confidence interval. So I want to mention, this is very important for project 2. The p-value tells us that, yes, we can conclude that women spend more time cooking. Okay, single women spend more time than single men cooking. The confidence interval isn't about do they spend more time, but it's about how much more time do they spend. So now we can say it's somewhere between 5 and 18 minutes a day, or maybe 19 minutes a day cooking, more than the men. Any questions on that idea? Very important to understand the difference between the hypothesis test and the confidence interval. So what we can say, there is statistically significant evidence to conclude that the population mean amount of time women spend cooking. Okay, and notice, by the way, actually, it should say single. Notice that this is the population mean. This is all women, not just the ones we sampled. Is larger than the population mean time. Men spend cooking. Any questions on that idea? Okay, now for the confidence interval, we can say with 95% confidence, the population mean amount of time, or let's just go actually, yeah, population mean amount of time women spend cooking is between, and this single men, and our numbers again were 5 and 19. 5 and 19 minutes per day more than the population mean amount of time men spend cooking. Any questions on this idea and how you can run a hypothesis test and also how you can create a confidence interval? Any questions? Any questions? I should let you know, when you read the book, remember there's a textbook that has all this stuff. This is one of the very few areas where when you read through this chapter 10 and you read about the confidence intervals, I actually wrote that because it wasn't in the original book. And a lot of people complained and I actually put it in because I agreed too that we should talk about confidence intervals. Any questions at all on this example? Okay, let me do one more example. And this one, I am not exaggerating. I made several $1,000s because of this example. Anyone guess what it might be? Okay, and it's not teaching because I make money teaching, but
Gambling?
gambling's a good idea. It's kind of a type of gambling, but not the kind.
Investments or trading? Investments or trading?
Yeah, investments or trading. Okay, so this is let me give you a story because it's a fun little story, and it's something that I do, and maybe you can too, and you'll make thousands of dollars also, and it happens from time to time when I can find it, and that is I watch the stock market, and I looked for patterns, I looked for trends, and I want to find out if I can find a trend that other people haven't found, I can make money. Does that make sense? So I found something, and it happened about 3.5 years ago that I started noticing it. And that was a president we had. Who was our president? Whether you liked him or not, there was a president of the United States.
Trump.
Trump. Okay. And something that everyone knew about is that every time he did something, he'd tweet about it. Do you remember that?
Yeah.
Okay. And, it was obnoxious maybe, but there was one really good thing about it. And let me explain. So every time he mentioned that he was going to zap China with some kind of, trade punishment, I noticed something. And that is the stock market went down. And then a week later, it came back up. Okay, I don't know if you noticed that, but I found out that other people didn't notice it. So then I went and I looked for a stock that specifically reacted to it. And have you guys ever heard of NVIDIA? They're a chip manufacturer for gaming chips especially, but for other things too. So I noticed that NVIDIA stock was doing that. So what I have here is a data that I collected personally on what I call tweet day and 1 week later for the price of NVIDIA. And what I wanted to do is I wanted to see whether it was consistent and whether the population mean stock price went up a week later after Trump's tweet about China. And he tweeted a lot about China. If you remember, you're watching the news, it happened a lot. Okay. Again, what I don't do is talk politics, like, you should like this person or not, but I will talk statistics. And what I found that no one else did is I found a pattern. So here's the question. And that is the population mean difference, does it go up 1 week later? Does that make sense? So the way I'm going to look at this is dependent data. The reason why it's dependent data is here was one tweet example where the tweet day it was at 106, a week later is 113. So for every tweet, there were two numbers I was able to gather. Then for another tweet, maybe the next tweet, 110 and then 124. So each tweet gave you two numbers. Any questions on that idea? Okay, so we write things a little differently now. First thing, we're going to have H naught. That doesn't change. And we're still going to have a colon. And what I can do is write the following. We're definitely talking about quantitative data. We're talking about a mean. But I'm going to write sub D. Any guess on what D might stand for?
The tweet day?
Good try. But the hint is this works for any kind of dependent data, not just tweets and not days. D stands for difference. So mu sub D means the mean difference for the data. So mu sub D equals 0 will be the null hypothesis. Because the null hypothesis is, yeah, it doesn't really change. Nothing to do with Trump's tweeting in terms of stock price. And that's the null hypothesis. The alternative hypothesis, H1, what do you think that's going to be? Let me write down mu sub D because it's about mu sub D. What's the inequality? Any thoughts? And it might help. Let's go here, and it might help to see it. First thing, we don't have two independent samples with statistics. Go back to the calculator menu. Which one do you think it is this time?
20?
Yeah, this is 20. It's dependent samples with data. And the idea is we have greater than, less than, greater than, or not equal to. It's kind of like, mu1 less than mu2, et cetera, et cetera. And the idea, if the second one is bigger than the first, then the first will be less than the second. So it's going to be a less than. Any questions on that? So that means it's mu sub D is less than 0. So the first is less than the second is another way of saying that. Or first minus second is less than 0.
Why is it not equal to 0?
You mean you'd like to have a not equal to sign? Because what do I care about if I'm trying to make a stock investment? Not that it's different, but I want, because if all I know is it's different, I don't know whether to buy or sell. Does that make sense? I want it to go up a week later every time, okay? Or at least the mean to be going up. So I don't want it to be different. I want it to go up from beginning to end, which means beginning is less than end. Does that make sense?
Yes.
Yeah, because the goal of stock is to make money. That everyone knows. I hope everyone knows that. So you want to buy low, sell high. And that's why it's a less than 0, because that means buy is less than sell, which is what you want. Okay, any other questions on that? Good questions, really good questions. Make it a little bigger. Okay, now we're ready. We can go right to the calculator. I've already clicked the calculator button. Data 1 separated by commas. I wrote this down. 106, comma 110, comma 115, comma 122, comma 114, comma 116. And data 2 is 113, comma 124, comma 120, comma 118, comma 127, comma 128. How about a confidence level of 0.95? Sounds good. And hey, calculate. What do you think? Do you think it would be a good idea to what I call play the tweet, which means buy when he tweets and sell when a week later. Good idea or not a good idea?
Good idea.
Good idea. We got a small p value. We have statistically significant evidence. And we can say it goes up somewhere between 70 cents and $14.96 on average. Okay, it's a small sample size. And do you know why I had to use a small sample size? What would have happened if I used a sample size over 30? Any thoughts? Because this is an example where I actually needed a small sample size. Okay, so let me tell you, if I had a sample size over 30, I'd have to wait for more than 30 tweets, and by then Trump's not president anymore. Okay, or not tweeting about China anymore. So sometimes you need a small sample size. This is an example. Okay. Again, this is slight gambling money. It's a little different than saving for college kind of money. But do you think I made money? Do you think I made a lot of money or a little money on this one? Okay. And the answer is a lot. Okay. So percent wise, I made more than 200% on my investment by doing this thing. So it works. Okay. Unfortunately, you can't just do this every month because it's really hard to find things that other people haven't seen yet. But I have found from time to time. Can I do this with Biden? Can I play the tweet with Biden?
No.
No, because he doesn't tweet all the time. But I'm watching Biden. I haven't found anything, but one of these days, maybe I'll find some pattern that other people haven't seen, and then I'll invest. But I'm always looking. So if you want to make money, that's one way of making money, and it works well. Okay, it's not 100%, because remember, if you have a 5% level of significance, for example, then you're going to go wrong once in a while. But most of the time, you're going to make money. Any questions on this example? It's a fun one. I like it because it's real, personally real. And I've done it from time to time on other things too with stock. Any questions on this example? Okay, so I want to recap what we've done. Let me write down there is statistically significant. It's not strong statistically significant because it's not less than 0.01. Statistically significant evidence to conclude that the population mean NVIDIA price is higher 1 week after the tweets I guess I should say was, because Trump is no longer our president, than it was on tweet day. Any questions on that? And not only that, with 95% confidence, we can conclude that not only is it higher, but the population mean NVIDIA price is between, now it was, let me remember, 70 cents and $14.96. Higher 1 week after tweet. then on TweetDay. Any questions on this example of dependent data? So dependent data, again, 1 day, 2 outcomes. Could be one survey question. It could be 2 survey questions to each person. So 1 person, 2 answers. So there's lots of ways it could be dependent. Whereas kind of the men and women thing, that was independent. Any questions on these examples? Any questions? I want to mention one more thing. And that, let me go to it. With Zoom, everything gets in the way, so it's hard to find things. Sorry. There it is. We could do this using this, because this is how you have to do the project, 2var stats. And let's get rid of all the numbers I had in there. So I just highlight, hit the backspace, they're gone. And let's put in our data. And for the first one, it was 106. And then 110, 115, 122, 114, and 116. For the second, it was 113, 124, 120, 118, 127, and 128. And now if we look over here, we'll see stats for dependent difference. This is dependent. And if it's dependent, then we can look at all the stuff for dependent. For example, our t-value, our test statistic, negative 2.82. And we had a left tail test. So it's 0.018. Which is small, is our p-value. Right now it says 99%. I'm going to change that to 95%. And there's our confidence intervals, lower bound and upper bound. So for the project, you're going to have to use this calculator. Any questions on the project? Okay, and you can do either dependent or independent. The main thing is you do the right one. So whatever your study is, you need to do what your study was. So if your study is independent, then you need to read the independent one. Nothing to do other than move your eyeball and see all this stuff. You can copy and paste that in your project. Whereas if your study is dependent, then you copy and paste these two. Any questions on that piece for your project? So everyone's project is either going to have this J and K or the N and O, but not both, either JK or NO for copied and pasted in your project. So whatever you're doing, whether you're doing dependent or independent. So you should all be at the point now where you're ready to come up with an idea for project 2, because project 2 is all about a hypothesis test for either independent means or dependent means. So it's what we just talked about, those last 2 examples. Any questions at all on the project idea?
Yeah, I have a question. In your notes, you said copy and paste your confidence intervals and hypothesis test and statistics list from the spreadsheet. That's what you're talking about, the dependent and the independent, but
Yeah.
also the data numbers?
And you don't need to copy and paste the data values.
Okay.
Yeah, that if you, I mean, you want to, you can, but that's not necessary. What's necessary is you copy and paste this, because this is the information.
Okay.
And it'll be either independent or dependent, not both, because of whichever your particular study is.
Right.
And some people do dependent, some people do independent. That's up to you. And what you should do, though, once you come up with your null alternative hypotheses, you should post it on the project 2 discussion board, and I'll let you know if it's going to work. Post the hypotheses, post what you're doing, and then I'll let you know if it's going to work. Does that make sense?
Yeah.
Yeah, and I'm always here to help you out. Oh, I want to mention something, a couple things. One is that normally I say that I'm always going to get back to you within 24 hours. That is not going to be true. Between 11:30, it might even be 11:20 a.m. on Sunday, and then Monday afternoon. Any guess on why I'm not getting back to you? It's not because I'm like angry at you or something. You don't have to guess. It's all right. I'm backpacking. So I'm going to be off grid. If you can find me out in the forest, good luck. You got a 20-mile hike to do. But just let you know, I always let you know if there's a time at which I won't get back to you. And that's a time. And that is Sunday. I'm kind of going to give you 20 minutes to make sure that those who happen to take the test on Sunday, if there's any issues, I'll be there to help for the first 20 minutes. And then I'm bailing. Because after that, you're in, and then then you should be able to just do the test. Does that make sense? So that's just a note. I like to let you know when I'm not going to be available online, and that would be the time is Sunday to Monday. It's Memorial Day weekend, so I figure I can do that. Okay, so just a note. And any questions about anything before we jump in to talk about the exam? Any questions about hypothesis test for difference or about the project? Okay, if there are no questions about any of that, actually, before I talk about the exam, since we can, secret word. So I figure no one's going to leave, because everyone wants to hear about the exam. And the secret word is dependent. So notice that the example that I just did was about dependent data. So secret word is dependent, an important word for this week. Okay, so now let me talk about the exam. So when is the exam? Who remembers?
Thursday, Saturday, or Sunday.
Yeah, Thursday, Saturday, or Sunday. And what I did is I just said it at the same time as I said it last time. That way you don't have to try and remember. The final will be different because the final needs to be finished by Wednesday. It's a whole different thing because I have to get grades and submit them and stuff. I can't wait till after finals week. I'm not allowed to do that. So instead, it'll be by Wednesday so that I can grade and get it all done. But for the exam 2, Thursday at 6 p.m., Saturday at 8 a.m., or Sunday at 11 a.m. Okay, and the rules of the exam are exactly the same as the rules of exam 1. So in particular, you're going to use Proctorio. So have your video and your microphone going, and you're going to be allowed a note card, which I happen to have in front of me. So one of these guys. So a standard 3x5 note card. You could put anything you want on front and back, and that's fine. You just show it to the camera. So same rules, not an issue. Oh, one more thing before I forget. This Friday, I don't have office hours. Sorry about that. Because there is one thing that trumps actually teaching in office hours when it comes to my job. And any guess on what that is? Something that's actually more important. No offense, more important than, teaching you all.
Your kids?
That's not my job. Now, if my daughter needed me, that's obviously more important, but I'm talking about my job. Okay, you probably wouldn't guess. I'm on a hiring committee to hire a new full-time faculty member, and we got to hire good people. So that's the one thing that takes priority over teaching is hiring people. And so I'm on that committee. So I'm going to be completely out during the day on Friday. I'll be checking email from time to time, but I won't be in office hours on Friday morning because I'm going to be interviewing hopefully a great person so that we can hire someone really good, because that's important. because you hire a bad person, it's a lifetime job or a career job, and it could be bad. So just a note, I will not be in office hours on Friday. Every other day, tomorrow, and so Tuesday, Wednesday, Thursday, I'll definitely be around my office there. I'll be checking email, I'll be checking the discussion boards to make sure that I can help you out, but just not office hours. Any questions on that? Okay, let me talk more about the exam. I just wanted to make sure I kind of went over all the things that are going, a lot of weird things going on the next week. Okay, different than normal. Okay, so first thing again, you can take the exam. It's 2 hours. If you have a disability and you need accommodations, you need to email me and let me know which of the 3 days you're taking it so that I can make sure that disability accommodations are met. Okay, and then I'll make it happen for you. But if I don't know, I won't know which day to give, to make it happen. So that's just something, email works great for that. Okay, so number 1, same as number 1 for exam 1. And you remember what that was?
Put your name.
Yeah, but it's not just your name, but you're stating that you're not going to cheat, basically. You're not going to be asking other people questions. You're going to be not talking to anyone except maybe your child. And you're not going to be using other devices like a smartphone to email people. So you're just taking the test for 2 hours, period. So that's what that is. Same number 1. Then 2 through 7 are true false questions. Okay. How do you practice true false questions? Where have you seen them before?
In the homework?
Yeah, and the homework had a bunch of true false questions. Okay, which I wrote, by the way. So, okay. And I should mention this particular exam covers everything we've done since the last exam. So this exam is going to cover chapters 7, 8, and 9. Okay. I know it's a lot fewer chapters, but they're pretty deep chapters. So, the last one was 1, 2, 3, 4, 5, and 6. Okay. But if you remember, we did like 2 chapters in a week because they were, shorter, less material. Whereas this time we have 3 main chapters. Okay. So the true false is going to be true false about 7, 8, and 9. Any questions on that? Okay. And again, don't leave any blank. That would be stupid because you got a 50-50 chance if you just close your eyes or, just randomly grab one, true or false. But better is to try and think about what's the reason why you think it's true or what's the reason why you think it's false. And then put that in. Okay. Then what I did is I copied and pasted pieces of the rest of the exam. Okay, so it's not the whole question because you couldn't answer number 8, for example, with all I've given you here. But it is state the null and alternative hypothesis. In fact, I think that's the problem when you copy and paste. That was number 1. And then number 2, let's see if I can make this work. Oh, I know, I got to go this way, I think. Let's do that. Nope, didn't work. All right. Number 2 was find the test statistic and the p-value. Number 3, write the conclusion in the context of the study. And number 4 is a question about type 1 and type 2 errors. So you've seen problems like this. Where have you had to do this? Very recently, that's a hint.
In the discussion?
Yeah, in the discussion. Your discussion assignment that was due yesterday. We got a question. This midterm will cover, I like to call it exam because it's not really middle of the term anymore. We're kind of towards the end. So it's the exam. The answer is not 5 through 8. It's 5 through 7. And it's not 7 through 10. It's 7 through 9. Does that make sense? So in other words, this exam does not cover what I talked about today. Does not cover hypothesis tests for the difference between means or proportions. So it does not cover chapter 10. And that's because I don't feel comfortable testing you on material that you haven't had your homework due yet, because that homework's not due till Sunday night, which is after the exam. So it's 7, 8, and 9. It's just 3 chapters, and it's week 5, 6, and 7. 3 weeks. Does that make sense? Okay, so note that you definitely need to do these 4 things. So what you can do, and I recommend, is a few things. One, so you can go back to the discussion board, look at my model, because my model goes through this kind of stuff. Okay, and it does full sentences on these. You can also look at my example that I gave last week in the webinar. Okay, you can also go through the full-length videos where I do this. So there's a lot of examples, and you can try doing it. So my idea is you watch the webinar video, but don't watch the whole thing. Just watch where I ask the question. See if you can answer 1 through 4, and then watch the next 10 minutes and see if you got the same thing I did. And that's a good strategy for practicing for this exam. Any questions on that? Okay, then number 9. And sorry about the numbering. I didn't notice this when I hit copy and paste. Number 1 is state the null and alternative hypothesis. Number 2 is write down the test you're using, calculate the test statistic and the p-value. And just so that we can put it all on the same area. Number 3 is use a complete sentence to state your results using the context of the question. Number 4 is the level of significance. I'll even tell you I used 5%. Represents a probability. Use a complete sentence to interpret the probability in the context of the study. Okay, and I want to mention something. The context of the question. The context of the study. And then the next one. The p-value represents a probability. Use a complete sentence to interpret the probability in the context of the study. If all you do is give me the definition of the p-value, that's not in the context of the study. Any questions on that? Okay, and similar with all these others, it's got to be in the context of the study. So if you notice, for example, in today's stuff, and I know you're not doing differences between, but it's the same idea. Notice that when I wrote with 95% confidence, we conclude the population mean price. So it's all, I write down NVIDIA price. Okay, that's the context of the study part. Tweet day. So those kind of words are in there. So whatever the question was about, you need to have those words in there. And you have to have the words population mean if you're talking about a mean. Population proportion if you're talking about a proportion. And don't get those mixed up. You lose points if you mix them up. So if you did this one and you wrote proportion instead of mean, I take off points. Any questions on that? Okay, so number 9, again, standard hypothesis test question. Notice I asked slightly different things. As I mentioned, I promised that you're always going to state your results, whether it's number 9 or number 8. That's right, your conclusion, same question basically. Whereas sometimes I'll ask about type 1 and type 2 errors. Other times I'll ask about interpreting the level of significance or interpreting the p-value. Okay, you only do that once each. But the complete sentence to state your results, that's every time you do a hypothesis test. Okay, number 10 is a sample size question. And there were 3 types, by the way. I'm not going to tell you which type you're getting. Depends on which day you take the test, by the way. And there was a sample size for a mean. There was a sample size for a proportion when you don't have a preliminary estimate. And there was a sample size for a proportion when you did. So I won't tell you which one because it depends on the day you take it. Okay. And that's, by the way, the tests are not the same, but they're the same style. So everything I've got written here is true for all 3 days, whichever day you take it. But, you know, the context is going to change. Okay, number 11, you're going to have to do a 95% confidence interval. Okay, and again, sorry, that should be number 1. Number 2 is interpret the confidence interval in the context of the study. And number 3 is 95% represents a probability. Interpret this probability in the context of the study. Do you remember doing the stuff with chapter 8? Hopefully you do, because you're going to have to do it. And practice, practice, practice. Okay, and I'm not going to tell you whether it's a mean or proportion. That could even depend on which day you take it. But it'll be a confidence interval number 11 no matter what, whichever day you take it. Okay, number 12, let me show you. For each, there's a part A. Write down the distribution. There's a part B. By the way, write down the distribution. What symbol must be in write down the distribution? You can put in the chat box. You could say it. I've mentioned this. It's been a few weeks since you heard it.
N.
What's that?
N for normal.
Okay, N is one of them. Yep. N is one. What's another symbol? It's kind of a funny symbol that you may not have thought about until this class. Whereas N, you've known N forever since you were a kid.
Sigma?
No, sigma won't be in there. There'll be a number for sigma, but it won't be sigma. It'll be like a sigma sub x bar or something. I mean, there could be a capital sigma, but there may not be, depending on the problem. A funny little symbol, not a letter. That's a hint. Remember? It's been a little while, not too long though. Don't see y'all jumping in. Remember the tilde? That little tilde that's kind of that shift kind of quotey thing above the tab on your computer. That little tilde thing, or the top of an enye, if you speak Spanish. It's a tilde. So remember that. Part A, that needs to happen. Got it? If you do not have that, what's going to happen? If I don't see a tilde, what's going to happen?
Lose points.
You're going to lose points. So do you want to lose points? I hope not. So I want to tell you this. You could put on your note card to remind yourself whatever it takes. I'm telling you because I never quite understand students sometimes on why it is that some people just ignore the question. And I'd say about a third of the students don't even bother answering part A. They don't even have a tilde in there. And that'll get you points right there, just the tilde and an N. But then there's more to it. Okay. If it happens to be for a mean, you're going to have a sigma over root n for the standard deviation and a mu for the mean, not the letters, but the numbers. If it happens to be for a total or a sum, then the mean will be the regular mean, the population mean, times the sample size, and the standard deviation will be the standard deviation times the square root of the sample size, square root of n. If you get it mixed up, you'll get it wrong. So practice, make sure you make notes of it. That's part A. Part A tends to be the hardest part, and I'm not sure why. It's not meant to be tricky or anything, but for some reason, I don't know, maybe people don't practice. Those who practice tend to do well. Those who don't practice a lot, and I can tell, don't do well. Part B is answer the question. So that's going to be like find a probability or maybe find the 48th percentile, something like that. And then you answer it. You're going to be using a calculator for that. Normal calculators, you might guess. And part C is, oh, you know what? Sorry about that. That was from last year. Let me put XXX. Okay. Determine if the assumption that, whoops. That one's XXX. That the assumption that whatever it was, and again, depends on which test you take. What I had was last year's, but the assumption that XXXX is normally distributed is necessary for your calculations. And again, if you're talking about means, then what's the key number? If it's quantitative data, what's the key number? Who remembers? Guessing you remember.
Are you
Huh?
talking about 30 as the sample size?
Yep, 30, over 30, over 30. Okay, if you talk about proportions, it's NP and NQ greater than 5. So it depends on which one you're doing. Any questions on that? Okay, and I want to let you know there are 3 parts, A, B, and C. Do all 3. If you only do part A or do part B, because that's what people do, then you're going to lose a lot of points for not doing A and C. Okay, and then there's going to be a number 1 and a number 2 out of this number 12. So there'll be 2 types. I'm not going to tell you what types, but there'll be a number 1 and number 2. It depends on which test you take. So that's 6 different things you have to do for number 12. And it's actually worth a little more points than the rest of the problems because there's so much to do. Okay, number 13. The first question is come up with the confidence interval. The second question is use a complete sentence to interpret the confidence interval in the context of the study. And the third question is, was the sample size large enough? That's that 30 and 5 thing, depending on what type of thing you're doing. Any questions in number 13? And that's the whole exam. So the exam has 13 questions, and hopefully you all do well on all of them. And you have the full 2 hours to do the exam. Hopefully that's enough. Do your best. But don't spend all your time on just the true falses or it'll get you, because the true falses are not worth as many points as these full long problems. Can you zoom out so we can see all the numbers? Oh, you want it to, yeah, I don't know if you'll be able to see, it'll be so small, but I can do that. Let's see, that's view, I think, isn't it? Thought it was under view.
I think if you go to the little 100% under insert, go into the, yep. and
There we go. Yep, that should do it. So 50%. Okay, you won't be able to see all the numbers because there's a lot here. But I'll show you at least here. There's 9 through 13. And there's 1, 2 through 7 and number 8. And I do want to let you know, to remind you, these webinars are always recorded. So you can always go back onto YouTube and look at the webinar and, get it. If there's something you didn't take notes on and you didn't remember, you can always go back for any of these webinars. Okay. And in fact, you can go back to 5 years ago and see what I talked about from my other classes, because it's not much different. Stats hasn't changed that much. The calculator is new because that's only a year and a half old because I built that. Okay. Let me go back to normal because it's really small. So that's the exam. And just a note, always good to look at study tools. So one of the things you can definitely do is, let's say you want to go and you want to kind of review the central limit theorem. You can always go back and say, click on Chapter 7 Central Limit Theorem exercises. You can click on that, and then you can practice the problems. Practice, and there we go. And there's a bunch of exercises, and you can practice. So those are always open for you. Any questions on that? You can also always go back to the discussions. There's different ways of getting to them, but I think the easiest is hitting discussions. And then you can go back to whatever week you want. And let's say you want to remember that confidence interval discussion question that you had to do. And you can look at, say, my post, and you can look at kind of an example, a wordy example that you're going to have to do a wordy example of. It won't be exactly this. That's another good place of getting stuff. You can go to the book, of course, because always available for you. A few ways of getting there. So you can go to, there it is. There's the book. And let's say you wanted to look at chapter 9 again. You just click chapter 9. And then that has lots of examples too. Okay, so there are a lot of places where you can go and review. Okay, I can't tell you what's best because everyone has their own type of learning style. So what's best is what you learn with. You can also go to the videos. And by the way, with LibreText Calculator in progress, I'm almost done. I've finished chapter 13. Okay, I didn't do 1 and 2 and 5, I think, or something like that. But all of these chapters are all done. So you can go up and review by watching this, confidence intervals with LibreText Calculator, for example. And there's a video, and you can, and there's some examples that I show there. You can also go back to let's say you go to the webinar on chapter 7 under week 9 module. There's different ways of getting to these. And then you can click play and it'll play for you. And that's the webinar. So there are a lot of resources to review different kinds of problems. You know, watching me do it, read it, try it yourself. There's more resources than you have time to do. So all I can tell you is you should do a lot of them, enough so that you get used to answering questions, so that you don't have to think for 20 minutes when you read a question. You'll look at it and you'll say, oh yeah, that's that question. And I've shown you what kind of questions you're going to be asked, and you know kind of the style of writing you need to write and what the process is. Okay, and practice until you get those processes down and the writing style down, so that you don't have to like stress too much because you know what you need to do. Does that make sense, or did I lose you anywhere?
I have a bit of a question.
Mhm.
As far as the 3-5x5 card, would
Mhm.
you suggest writing more equations, or for these chapters, write maybe the templates down?
Okay, so first thing is there are no equations that you are required to memorize or even use, really, because you have a calculator.
Well, like for number 12, you were talking about the write down the distribution, and you gave us a couple examples of
Right, yeah, so those, yeah, I guess, okay, that would be the one. Okay, and there's 3. That's all there are,
Okay.
right? There's sigma over root n, sigma times root n, right? So, or there's like mu comma sigma over root n. There's mu times n comma sigma times root n. And then there's p hat or p comma the square root of pq over n. That's it. That's all the equations for the entire exam that are needed. Does that make sense?
Yeah.
Yeah, so I guess there's those. I forgot about those. Yeah, and put those down. You can put those in a very small area of your card. I would put it in the same place because, it's under the same chapter. And those are the only equations really, right? I'm trying to think if there's any more, but for the last 3 chapters, that's really it. Okay. On the other hand, there's a lot of stuff to do. And anything that you don't have in your brain, even when you're stressed, you probably want to put on your card. Does that make sense? And that could be template examples. Okay, those templates, whatever helps you. And it's hard for me to tell because everyone's a little different. Does that make sense?
Yeah.
But there's not a lot of equations in this stuff. There's a whole lot, but I did them and they're in my calculator. Does that make sense?
Yeah.
Yeah, I mean, there's like 100 equations, but you don't have to know any of them except for those 3 little ones. Okay, good question though. Other questions? Other questions about the exam or anything else too, but right now the big focus is the exam. Okay, and just let you know, I'm usually hang out for the first like 20 minutes or so. After that, I'm just staring at a screen because you should be on at that point. So I'm there to help you, but I'm not on Zoom. So I'm just on email if you can't get in. And a big reminder, same as exam 1. What do you do if it says put in your access code when you first try and get into the exam? You remember?
Restart?
Yeah, restart. And you don't have to necessarily restart the whole computer, but maybe close the tab and then reopen it. And that usually works. Try it a few times. That usually works. It's a pain in the rear, and I don't know what to do about it. It's just a Proctorio thing. Sorry. I hate it. So there is no access code for this exam, period. Okay, but for some reason, Proctorio gets confused. That's the main thing. Okay. But otherwise, it's the same. It's the same as what you did before. And by the way, the final is going to be the same also. Okay, and then I'll probably start grading it Monday night or Tuesday. Okay, because I'm backpacking Sunday night and Monday. Because I got to have fun too. But that's what you can plan on.